Okay, I can go ahead and drive. Where's there it is. You want to intro us while I get it going?
We can't hear you.
You
There
can't
you
hear
go. I'm like talking and muted. No, thank you, Marco. This is backend pairing for July 19th, and we're going to be working on a refactor. And it looks like it's going to be something in remote development.
Yeah.
Ooh, development, yes. I
So
will be looking at that sooner or later.
I'll give some background here. What we're doing is, so it's a greenfield feature. It just hit, early this year. And before we start adding more features, we've made the decision to refactor this to some functional patterns that will make it easier to work with, because it was already getting a little bit coupled and complex and convoluted and hard to follow. And the pattern we're using is this railway-oriented programming. It's a common functional pattern just based around the result type. And this is a really good presentation that sort of explains it. We'll go into it here. And so we had sort of 4 subdomains to currently to the remote development. There's the workspace update, the agent config update, the workspace create, and the workspace reconcile, which were sort of in increasing orders of complexity. And so we've broken it down. The first 3 parts are done, and I'm on working my way through the 4th part here. And to show you sort of what one of the existing ones looks like. So let's start with, just the service. And we'll look at the update service. That's the first one we did. So here's our service. And we intentionally are trying to have this hexagonal architecture that goes along with our direction towards a modular monolith, where the domain logic lives in the middle of it. Here's an article that talks about that. And this is linked in the README. I missed the README, but sort of there's these architectural layers, and ports and adapters is another way to think of this. So your domain logic lives in the middle here, and then there's services around that, and then there's the other, your API is around that, and then these have ports and adapters of how they talk to the different layers. And I've also, in our domain folder, in EE lib remote development, there's a README, which, whoa, that's a bad link. Why is that a bad link? Oh, oops. This is now on master. And like, here's the TLDR, quick start, like if you're just working on this, but the overview, and this is sort of a simplified version of that diagram. And so it's square, not hexagonal. And then, so we're doing some new things in here. We have some type safety. There's some interesting things you can do in modern, in Ruby 3 that can give you some type safety, which is cool. We also have yard. And then this talks about some of the functional patterns we use here, as well as the standard OO patterns. And then here's the railway-oriented programming, which is based around this result class. And like, here's the code I was about to show you, but there's basically nothing to the service, right? All it does is call the domain logic, which lives here under this main method. And it's a singleton class method. We don't have any instances because we don't want state. There shouldn't be any state in any of this. And we pass in the stuff, and then we just get a hash back from that. Like, it doesn't return a service response because that would be breaking the boundaries between the domain logic and the service. The service response lives in the service tier. And that would actually be a circular dependency in terms of like pack work, because the service class would be depending on the business logic, but the business logic would be referring to service response, which lives in the service tier. That's a circular dependency. So that's why we just return a hash here, and then the we have this little helper that turns that hash into a service response. So the actual domain logic, like I said, the workspace update is really simple. And we can talk more about the pattern. I don't know how deep you want to go into it, but it's basically a result, which is an object that encapsulates something succeeded or failed. It was okay or error. And then it's a monad, but you don't have to know that word or what it means, or that it's not a burrito at all to understand how this works. It's just, we start with this concept of a result, which could be okay or error, and then you just chain the different steps of your business logic you're doing, and you pass a higher order function. We're saying, okay, then we're going to call this method, if the first thing was successful, which in this case, all it did was wrap up the data we were passed in. And then if the authorize was successful, then we're going to go ahead and do the update. If the authorize were not successful, this would short circuit and fall through and not do anything after it. And then we have this concept of we're just returning domain messages. And so like if it's unauthorized, we pattern match on that, or if the upstate failed, we generate an error response, which this just gets turned into the service response as we saw with the chain. And if it's successful, then the context contains the workspace update, which then gets stuck in the service response and returned. And
I have a question.
Sure.
First of all, this brought me back to the university on the programming languages class, talking about monads and higher level functions.
Don't even need to know that word. It's just a result means something succeeded or failed, either or.
Yeah. I didn't like that class. Okay. Anyway, that initial result and the calls to and then what happens when, for example, the authorizer doesn't succeed? That's going to stop the execution, right?
Yeah, well, we can look at it here. Like we can look at the updater, which has the example here. So it comes in, and this logic is in the result class. So these and thens that you see here is just a method here, and you get passed in the lambda or a method object, and it does this check like, is it successful? Okay, we're going to pass it along. Did it fail? Is it an error? Okay, then we're going to short circuit everything after. And the names of these methods and everything are basically exactly based on Rust. And the result type is a standard pattern in all functional languages that you'll see.
Mm-hmm.
Does that explain it? So like here we can see, the and then unwrapped the value out of the result, right? The okay value, and passed it along, which is what we got here. And then we use this, it's called right word assignment. It's a Ruby 3 thing. We just are destructuring this into the two keys, but it also gives us some type safety. So like if this happened to be nil or the wrong type, it will blow up immediately with a language error. So finally getting a little bit of type safety in Ruby. Whereas before the best you could do is like value.fetch workspace, and like that at least would make sure it's not nil, but you wouldn't know it's the right type. But
that's only a runtime check though, right?
Ruby doesn't have a compiler. Everything is at runtime.
Oh, yeah, right. Good point.
Unless we do static analysis.
Yeah.
So yes, that's the best we can get. But when you run your tests, it's before it's actually in production. So that's type safety. And so like we've destructured out these two values, and this is like what you would normally see in the service, except it's down in our domain layer, encapsulated in this one step that is decoupled from everything else. Loose coupling is good, and it's cohesive. It does a single thing. All it does is the workspace update. It doesn't do authorization, doesn't do anything else. High cohesion. So the root of all that is good in software. Loose coupling, high cohesion. So this is the answer to your question. We just do the update, and same thing. Check active record is going to return, true or false for this, and you wrap that in the result. if it was okay. And this is just the domain message, like I said, rather than trying to throw exceptions. Like the whole point of this is to avoid using exceptions as control flow. And especially in remote development, like in the reconcile that we're doing now, there's like, we're processing multiple workspaces at a time, like lots of things could fail for an individual one, but we want to keep processing them. We want to be able to log, trace, perhaps record that. So the decoupling of all of the failure handling and messaging is the whole point of this. That can now live up, at this level, or in something that is like, okay, we got a failure here. Here's what we do in this case of this failure. And all of that error handling and reporting and tracing and logging and everything doesn't have to live here with the actual domain logic of doing the work of the update. Does that make sense?
I like it.
Everybody, I was worried. I was like, man, this is crazy. People are going to hate it, but most people have liked it, especially the people on the team. They're like, oh man, this is easier to understand. I'm glad we're doing this before we write more code.
Yes, because it's
But they're
also
also Go programmers and people who know Rust and stuff, so they get it. Whereas the standard Ruby paradigm of like, everything's a mix-in. Who knows where it comes from? We don't. Like they they much prefer this.
no, it's also easier to understand the flow of things, because if you have if you use exception, they can come from anywhere in the chain.
Right.
While using this pattern, it's very much easier to understand where something is failing.
Right. And there's some nuances we debated. Like these messages are only for expected failures. Like we got some bad input. This is something we expected. We're going to wrap it up in a domain message and it'll get given back to the user as whatever message, maybe logged, maybe whatever. Unexpected message out of memory, the network failed, something like that. We don't catch those. Just let them bubble up to the top. Rails will wrap them into 500 like it always does. So like you're not going to catch every error here, only expected errors that are like due to input. And that's a nuance that we just debated a lot. So looking at the code, like you can see all of our service layer, there's like nothing to it. And I'm in the process of rewriting the third one here. Here's the agent config. So that's intentional. Like that's the hexagonal architecture. There is no domain logic here. None, because it doesn't belong there. It belongs in the middle of the hexagon. And if you look at create service, for example, like this one is more complex. It's got multiple steps. It authorizes, it fetches the dev file, it pre-validates the dev file, then it flattens it, which is actually calling our gem, which wraps this dev file CLI, which does other validation. And then there's some more validation we do after it does, that thing does its thing. And then we define our volumes, and then we inject various things into the volumes. This is all setting up the Kubernetes environment for the remote development workspace, or defining the dev file, which will define the remote development environment, and then actually create the database record for the remote development, which contains this flattened, processed, validated, everything dev file. So then, and then the way remote development works, it's based on GitLab agent for Kubernetes, which is over there somewhere in a Kubernetes cluster, like polling through CAS, through the agent for Kubernetes. And then it's always saying, hey, you got anything new for me? And then that's the part we're refactoring now, the reconcile, which will say, yes, I got a new workspace with a new dev file. Here, go do your thing on Kubernetes, and it does it. And so you can see here, like even when I refactored this, I was like, man, I had to completely re-understand the logic we wrote, which was already getting a little bit nested and convoluted and hard to follow with exceptions. And now it's like, boom, 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 boom. It does everything in order. That's the intro to what we're doing. And so now I'm on the reconcile part of it, which is turning this existing code like this.
Oh,
and tearing it apart, right? And this is like just the top level. Like then you go into the agent info parser, which does this, and then there's the actual state calculator. There's like this nested hierarchy, but now it's going to be at this railway oriented programming where these will be like clearly defined steps that can succeed or fail. But this particular one is trickier because we have to loop over them and handle any possible error that could happen for a single workspace, but still go ahead and process the others. Because the agent, when it sends a reconcile request, it's like all of the workspaces reconcile at the same time in the same request.
Yeah, that kind of breaks the linearity of that pattern.
Yeah, it's like going to be nested. So at the top level here, what we have in main, there's like, okay, first the request we got from the agent, we're going to validate it. Then we're going to extract the parameters out of it. And I'm sort of making this up as I go because I have to figure out what this is going to look like in this pattern. But then there's this reconciler. So like I haven't written yet, but it's basically going to contain all of this logic, which needs to say, okay, loop over these things. And as you loop over them, it's going to be a collection of results. And each of those could be an okay or an error, but we're going to pass them all along. And then at the end, all of the ones that were error, up here at this level or somewhere, we'll do our logging, reporting, writing them to the, our versions log. We're eventually going to want to keep a version of everything that happened to every workspace. Like all of that stuff will be decoupled, at this level or, probably at this level, but like not in the individual places where the errors actually happen. We'll capture those. Thoughts, Terry?
The original code looks wild, so I'm kind of interested to see, like, how do you decide, like, I guess, how to break that out? Like, I think it's kind of like is in the same line of what we talked about before. So like going through the process of taking something that's like funky and chunky and like getting it into something workable without, 3 hours later looking and being like, okay, what did I do? Everything is broken.
So I'm cheating here because I designed this code originally and I knew we were going this direction. So you notice here, there's no inheritance. That was one of the problems we ran into. It's like, oh man, this is coupled through inheritance.
Well, last time, oh yeah, that was wild.
Right, the one we were trying to refactor, Yumi and Casio, and we failed because there was that coupling. It was coupled through inheritance. It was coupled through modules. It was coupled through instance state. This has no inheritance. It imports no modules. It is a class method, or it's going to be a class method, but it has no instance state. That coupling isn't there. So now it's just a matter of, even though this is nested, that's true of everything all the way down. So that all we need to do is rip apart the pieces of logic and put them back together, but we don't have to worry about those unsolvable coupling, other things.
Like, where is this thing pulling methods in that I now need to figure out what to do with? Okay.
So this is a much easier case, even though it's still complex, because we don't have to deal with that often unsolvable coupling. You're just like, man, okay, I got to rewrite everything before I can even start to clean this up. Whereas here, no, we just need to clear that.
Yeah. Okay. I mean, it's not technically cheating. I feel like it's just like experience coupled with like the future state that maybe you're like, I want to get somewhere else to not, and this code is how old? Like months. And
I wrote the initial prototype last Christmas.
Yes. So we don't have the 6 years of history.
Exactly.
Which helps. But
introducing these functional patterns and enforcing them this way, and everything is a class method, and the README that explains exactly how we're going to do it.
Yeah. I really actually love that README in the folder, because I feel like you onboard a new team member or some community contributor that wants to come and poke around in here. That's so helpful.
And Gregor's recommended that, which is a great idea. And it's a much less friction than trying to do it in the docs with technical writers, because you really don't care that much. but yeah, like, and the other good thing about this, these functional patterns, like they're, even if you don't read the README, they're like difficult to break. You can't just go off and say, all right, I'm going to make an inheritance here, you know, pull in a module. It's like, that is completely against the pattern. So it's harder and much more friction to have this rot and devolve into something that is hard to maintain because of the functional state and the clearly defined patterns. So I rambled a lot. I don't know, I hijacked this pairing, but where I'm at is that's what I did. I like, all right, there's, before we actually start looping, there's the three things we did, which is like validating them. And the way this works, it just sort of, this value that gets passed along is just this hash. And like everything that it processes along the way gets added onto that. And then each step just pulls out whatever it needs and works with it. And I, like you could say, you're only going to pass along what the next steps need. But I personally like keeping everything, because then when you're debugging it and you put a breakpoint, you know, like in the very last step here, like, man, something's broken, I put a breakpoint here, you can look at all of the previous state that these other things have worked with and say, well, where did this come from? What was the state of the original dev file before it got flattened? And, you know, where did this bug come from? So just this value, just this big hash of everything that gets passed along, and things pull out what they need. I like that pattern.
And is everything, like every step does some computation and might change that state that gets passed along?
It could mutate the state, right?
Yeah,
I mean,
but
it's really a lot like Redux or Vuex or something. Like there's this immutable state, right? But within it, you can change it and then pass it along to the next thing in the loop, you know?
Yes, but you said that if like I'm in a level that in a step inside of this chain that changes some value, and you don't want to pass only that value on, you want to pass everything, so that in the end, you know, you have a full view of what happened. Do you also know what step changed what?
No, it's more like when you're transforming it into a different, you know, structure. Like for the dev file, for example, we start with, you know, just it's a YAML file, but it's like a minimal one that the user checks into their repo. And then in this flattener step is where it gets, we pass it to that gem, which is wrapping the dev file CLI. Like this is a standard for how to do remote workspaces. And then it gives you back this other YAML that's like bigger, expanded out. It has stuff injected into it. It's pulled in remote parents and stuff. So like that is why if you were to look into here, right, this gets the original dev file YAML, which is the original one. And then it spits out this process dev file, which is a hash representation of this more complex thing. But you still down the stream, you can see what the original YAML of it was.
Yeah, but if you were to override that file YAML, you wouldn't know what the beginning was.
Exactly.
So
I could have just made this like data and rewrite it every time, but I intentionally didn't do that. I gave it a different name and a meaningful name.
Yeah, so the key part is, okay, change the name of what we are processing so that we keep the history, basically.
Right. And I'm always really, I put a lot of thought into naming things because it's important. Like this one intentionally, it's a YAML file. So it's named in YAML. This one doesn't have YAML because it's a hash, right? Like I could have just named this dev file, but by looking at, once you understand the standards, by looking at the variable name, you know this contains YAML just by looking at it, not even having to know if it's a string. So where I'm at, like I said, I just, and now you're probably going to see me flounder. Like I said, I'm slow plotting and methodical. Like, how do we break this up? We need to somehow do what we're going to do here, each with object and loop over them. So my plan, like the algorithm here is like we have these, the request came in and it's these what we call agent infos. And that's just an array of JSON, which in this case they've turned into hash, that came from the agent K. And each of those represents like the information about this workspace, the current state of it in the remote development environment, right? And it could contain an error, and we have to calculate, it's like Kubernetes sort of specific stuff, and we have to translate that and turn it into what we call like an actual state, which is like, is it running? Is it restarting? Is it terminating? Is it terminated? So like all of that is sort of this part of the logic. And then there's this concept of the desired state, which is the user on the UI, they click the button and they said, I want to stop this workspace. I want to start this workspace. I want to restart it. I want to terminate it. And this reconcile is bringing all that together for each workspace. So like we take this raw JSON hash data from the Kubernetes for each workspace, loop over them, we turn them into a value object just so we're not working with the hash. The value object pattern is just like, rather than working with the raw hash, you know, it's an OO pattern. This is not a functional pattern. It's like, just throw it in here so you have nice methods to call on it rather than always having to dig into a hash. And it's also type safe because you know that it's exactly that data. And then we look up the ones in the database that correspond to the request from the agent, right? So then persisted workspaces from agent info, this is like, all right, here's the database records that correspond to the ones that we got in the request from agent K. And then we say, are any of them orphaned? You know, report an error for that. And then we say, okay, maybe this one, you know, we had requested it to be terminated. Our desired state was terminated last time. And then on the last reconcile loop, okay, now it's been terminated. And we need to update that actual state in the database to say, yes, this is terminated. And then that gets displayed in the UI when it's persisted in the database. And then there's a concept of like a full versus partial reconcile. I won't even do that. But then the final step is, so then we have to say, okay, is there any new workspaces? Like since the last reconcile loop, has somebody requested a new one to be created? If so, we need to let the agent K know about that so it can apply all those Kubernetes resources and create it. So then the final step is like, all right, we call Rails infos. There's like agent infos, the stuff that comes in, Rails infos, the stuff we send back. And we gather all those together, which is like either an acknowledgement that we've applied this new information you sent us about the state or whatever, or an error, as well as any new workspaces that have been created since the last time you did a reconcile loop. And then we send those all back to agent K, and it does its thing with all of them. But in each of the steps, so it's like multiple loops that loop over things, but over different things, and then spits out another loop, you know, like the agent infos, and then all of the workspaces for that agent info, then any additional things from the database that we found, and then put that all together, transform it into the format that we're gonna, as JSON, pass over the wire back to it. So that's the algorithm. And my thoughts, any questions on that?
No. Oh, go ahead.
It's just trippy.
Trippy?
Yeah, it's not my
a complex thing, which is why we want to break it up and make it simpler.
Yeah. I'm hoping
but-
like I can like see almost like these chunks in the pattern. Like if you kind of squint at the code, like I can almost like, are there like 4 or 5 places in here where each of those things would be one of those like, then blah, 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 and then blah, 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 blah. And so
Yeah.
is that like the plan to kind of like chunk these up into those sections?
The difference is like here, both in all of these previous ones, we're working with one thing here. We're like creating a thing where agent config, you know, we're updating a thing. And the workspace update, we're like updating a thing. Here it's different. We're like, okay, we got this request that represents multiple things, right? First thing we do is make sure that is okay and like extract some data from it. Then the actual reconcile, which is going to be loop over those multiple things in multiple ways, and then do whatever we need to do at the end. So the way I'm envisioning it is this reconcile, like, and you can actually nest these things. I forget where else did I do it in here. Yeah, so this pre-flattened dev file validator, right? So this is a step in the top level in the main logic here, but it itself has this nested pattern because this one step has some distinct substeps that it does in here. And they happen to be private methods, but we're still breaking them up with the same pattern. And so in this case, I think for the reconciler, we're going to take, the workspace Rails info, or sorry, the agent infos that we get passed in, this thing extracted, right? It's actually going to be in the params here, the agent infos, because we pull them out of the original params. And what it will be is multiple loops over those. It won't be a result and then. We'll use standard Rails, but like functional patterns like this dot map dot each with object dot whatever we do, which will correspond to how we're doing here. Like there's an each with object, there's a loop. And then here's, mapping over to find all of the persistent things and add that to the ones we found. And then here is like the updated workspaces, persistent workspaces with info. It is sorry, where's the loop here? This one, here's an each. That's the thing that saves the data coming from agent K into the database for each one. And then here is the loop, putting them together, the ones we got plus any new ones. And then finally, there's the loop like build for each one of these, the response. So the way I'm envisioning it is that there's going to be in this reconciler like multiple of those loops, and then each of those will be just a call to a class singleton method that does its thing, which maybe that will break down and be more hierarchical. But
Let's try one, because I'm looking and I'm trying to see.
Yeah,
I think I need to see.
It's like cohesion, right? So that all this reconcile is going to have is like the logic to loop and process over these things, but the actual logic of it is going to try to be extracted out to other classes. So yeah, what will it look like? What's the first thing well, let's look at the data we get in here. So the, trying to remember, workspace agent info. So that's the name of this key. And then that gets passed down to here, we validate it. So this is just flattening it out. So it's like putting the agent, that's like the thing on the Rails side that sort of received this request. It's sort of an internal API call. And then we took everything that was in the params, which was just the workspace agent infos and the update type, and flatten that out to the top level of this value so we can pull it out. So we want to loop over workspace agent infos. As far as TDDing this, like I kind of tend to look at the logic and write it and then backfill some tests for how I think it will work. But this is the most complex one. So first, starting by destructuring the value. So value, we do the right word assignment, and it's like going to be workspace agent infos, and that should be an array.
After you destructure the value, can I try explaining what I would do to see if I understood it correctly?
Sure. Let me throw this over there. Open and split right. I guess they changed the name of that. So yeah, we're like, this is sort of where we're at doing this stuff. Go ahead.
Yeah, like those, it's almost 3 or 4 loops, if I remember correctly. And those loops are not really related to one another. They are just computing, like I'm doing the first loop to compute some stuff, then I'm taking that stuff and passing through the second loop and go on like that. So it's kind
Maybe
of
updating the database, maybe getting some additional database info to add in. Yeah.
Yeah, so basically this is already structured to be like the other chain that you showed us before. So
Right.
basically you
We're just going
could,
to tease apart all of the logic into cohesive modules and leave only the looping structure as its cohesive piece in the reconciler.
so basically you could almost take those loops one by itself and create a method around that, and then basically create that and then structure calling each method one after the other.
So the thing about the and then, that assumes that you're passing along a result, right?
Yes.
That implies there's something that could fail. But the one thing I didn't mention, like if you look at this one, for example, there's this and then versus a map, right?
Yeah.
And if you look at one of the and thens, you see they return results because they could possibly fail.
Yeah.
But, and this is exactly like the REST API, these exact same name and behavior in the REST result type. But map, if you look here, it's similar to and then, but it's used for methods which always succeed.
Okay.
Right? And if you look at one of them, they get a value, you know, even the and then gets a value because it was automatically unwrapped, but they just return a value directly. And then the framework wraps it back into a result.
Okay, so it's easier. You wouldn't have a chain.
Always a result, okay.
Yeah, you wouldn't have a chain of and thens, but a chain of maps, basically.
Right, so that's why the reconciler is a map, because like it can't fail. All it's going to do is go over, loop over these things. The individual workspaces could be in some failure state, and they're going to be results. But what we're looping over is going to be an array of results. So we sort of have to wrap these. And so, like that's a long answer to your question. This is just going to be plain logic. We don't need to have the and then at this level. But we need to wrap. I think the first thing we want to do is wrap each workspace agent info in a result. And then that's what we're going to be looping over and passing that array of results along.
Yeah. Okay. But what happened? What if, for example, a database update fails? That's an error while looping.
Yeah. So like if it failed due to a validation error, right? That meant, honestly, like that should be a bug because this data originally came from Agent K, which is Go code that lives in GitLab Agent for Kubernetes project, but we own all that code. So like if we gave it something that couldn't be applied in the database, like there was no user input involved. So if that failed, it's a bug. But the way we're going to structure it is ordinarily you would just let that bubble up. And in these cases, you know, for example, in the update, like here, if we're not catching any errors here, right? If this we just say it failed or not, but if it did some other unexpected error, we let it bubble up. But in this case, we're like, even if there's a bug, we don't want to fail to process every other workspace in this request, because then the whole feature is broken. Like, so we don't want to let that bubble up. There's no downside to letting the error bubble up in these things that are only dealing with a single thing, because whatever, your thing failed, there's nothing else happening here. You're not going to affect anybody else, and your thing wasn't going to work. Here, we have to think about it differently, because
You have the
matter
same
what-
problem in indexing when we are indexing like 1,000 unrelated records. If one of them fails because like some weird reason happens, the other 999, they should be indexed, and we shouldn't
Same
like,
thing.
like explode the whole thing. So that totally makes sense.
Yeah. So, and that's why each of these will be a result. Like, we're going to pass along this array of results, and then at the end, you know, probably here, or maybe we'll add another, probably add another step here at the end, which is like process, you know.
Can you like requeue
available.
failures or something, or?
Yeah, and that's sort of the whole point of this. Like, we haven't added it yet because our error handling is, because we shipped the absolute MVP of this. There's kind of no error handling or logging or anything good. And Hunar is currently working on that. So like, this gives us a very methodical way to say, okay, now we're going to do some logging to Snowplow and writing the state to the database, and maybe logging it to the, you know, the error tracer and whatever. All of that can be done decoupled and cohesive from the actual, you know, the error happened. Okay, all we do is throw a message. I think the one thing I didn't show you is like how these messages work. So the result, just the okay and the error, they can wrap anything. It's like whatever you want to put in here that represents your okay or error is fine. But in our case, and that's why this lives in the top level, this is in lib. Anybody can use this, it's completely generic. But our failure messages, it's just classes here. And this follows exactly that presentation that I showed at the beginning. And so these are type safe, and that's what lets us, you know, pattern match on them in a nice way here. It's like, if your error is unauthorized, do that. If you're, you know, any of these errors, we do a specific thing. If it's successful, we do a specific thing. And each of these is an instance of message, which just has a context, which in our case is like, it's just a hash of information that you're passing. It could be, you know, why it failed, an array of messages, an active record errors object, stack trace, if for whatever reason that mattered to you, anything. So like, I think the first, so we need to do this logic here. Like, we can even throw it in here as a placeholder. And comment it out. So I think the first thing we wanted to do is turn these into results. So map over the workspace agent infos. Whoops. Map. Whoops. And it will be result.ok of that. And what do we want to name that variable? That would be
workspace agent infos results.
Results, yeah, probably. Like too long of a line.
Yeah, I also like giving very explicit names, but that fights very hard with the line length limit.
Yeah, so I always, I don't mind. I make it, I just put it on multiple lines. So you can see I have my nice benefit from that IDE telling me what's wrong. Oh, I got some trailing white space, hit F2, variables not used. Okay, that space shouldn't be there, and the line's too long. All right, so we'll fix the line length. Well, Command Option L, auto format to get the space. Save. That should get rid of our errors. So the variable's unused. Huh, that line's too long. Okay, whatever. Too long now. Then we want to loop over this, right? So it's going to be this same sort of loop. But do we want to have this logic here? No, we probably want this logic to live maybe in another class, which is the, we already have the corresponding agent info parser here, right?
Yeah.
Which is the, all this is doing is taking the structure and turning it into this value object from the hash. So here's where I'll have to think about it more because, and I've talked a lot about this with Paul Slaughter and like how this works in Rust, but it's kind of different. Like we have the array of results, but in here that we can pass around, but when we're converting, so we just wrap it, workspace, like these are really the the naming is a little off here because this is a hash, and then what we return here is like them by name. So maybe that's what we want to get out of this. Workspace agent info is by name. Or is the, and we basically could pull this out to a new class and have it there. The looping part, we already have the agent info parser stuff here. We could sort of transform this to take, but this is only dealing with a single one, right? So, and this is where I said I would flounder. Like, how do we want to handle that we've wrapped this up in results and convert this? We may have to be manually unwrapping results and other stuff. And with that cliffhanger, we're almost at time.
Okay, we have to do this next time, or at least like post in the channel with what it ends up looking like.
I gotta get
Because
this done like by next week. So
would
I
you just
don't-
like post in the channel afterwards so we can look at the MR when it's done? Not
Yes.
to, yeah, you can't work on your stuff until we have another pairing session.
Yeah, and pair programming is, like I said, I did it for 13 years straight and it's great. But this is the point where, like when I'm solo and I don't have the pair to talk it through, sometimes it's good. Like at this point, I'm just going to sit and stare and think about this for like maybe an hour and then try something.
Yeah, no, that makes sense. I
It's
mean,
kind of
sometimes
boring
I'm
for
like, I
video.
want to go work on something small or like go fold my laundry while I think about this thing and then come back to it. And it's like unstuck my brain a little bit.
I mean, what I'll probably do is just like try something out and see how it feels and
Yeah.
then see what that looks like. And then if it doesn't, then I'll iterate it from there. But
That's
yeah,
the nice thing about a refactor. You can go and be like, nah, this don't feel right, or it doesn't work right, or the
Right.
return object that you get doesn't look right. But I really appreciate you walking through this with us. Yeah, I will just say if you do end up getting the MR up and merged, if you wouldn't mind sharing in the channel, because I am interested in what it looks like.
yeah, and I think this will be really good to like keep around for onboarding people to this. I'll like link to it in the README.
Yeah.
Yes.
It was really nice.
What do y'all think? Is this like crazy talk functional programming is going to confuse everybody, or is it a good thing?
Oh, I think it's a good thing because it's really easier to understand the flow of things. And to be honest, last time we had a chat, me and you, I told you that I don't like functional programming, but I'm starting to change my mind.
I would tell you, Marco, I technically, like most of the time, I just don't like things when they're new. I'm just like, this is new and I hate it. Or I'm not used to it. Maybe that's similar for you.
Like the first, like I had been coding probably 20 years, and I went to, like I was going to go to a conference in Mexico and I got canceled because of Zika. Anybody remember that first pandemic? But I went to LambdaConf in Colorado instead, which is a functional programming conference. And I went into those talks and I'm like, I don't even know the words they're using. I have no clue what they're talking about, but this seems amazing. And then when I actually started doing it, like I did a little bit in Kotlin and I did a little bit of Elm. And what I realized is, you know, you think about the test pyramid, end-to-end test at the top, you know, user interface, unit test at the bottom, and then the middle is the, what I call it, is everything glued together in the right area and the right type and no bugs wiring it up layer. In strongly typed, null, you know, non-null, null safe functional languages, you don't have to write tests for that layer. It's like it won't even compile, it won't even run if you don't have that stuff right. And then like when I went back to writing vanilla JavaScript and vanilla Ruby, I'm like, oh man, I have to write all these tests just to catch my own stupid errors, you know, so they don't happen at runtime. So that's why I'm like, yes, I want to embrace that part of it that just eliminates my need to test that wiring and get that a little bit of type safety that we can finally get in Ruby 3. Yes, let me have it. Catch my stupid errors so I don't have to write tests for them.
No, yeah. I don't know. I feel like just being like flat out like no against anything for me is just not I don't know. I try to be open-minded. I won't say always am, but I don't really have I went to Strange Loop, which is I think one of the other functional programming.
I'm going to the last one this year. They're
so jealous.
Yeah, it's great. I've gone twice.
I never got to use that at work, but I remember just being like, oh, it seemed pretty cool when I was there. So but you know, I think it's interesting. It'll be cool to see like where remote development is in 6 months and kind of see how far y'all have been able to take like the development style that you're encompassing, and maybe that can be something that other teams start to embrace.
Well, it's greenfield, so it's a great place to try this stuff out. And the other thing, it really supports the efforts to clean up the monolith and the modular monolith. Like by definition, like it's got an extremely clean domain layer and boundary, and it's hard to break, and the dependencies are extremely explicit. So
yeah, after our last debugging session, yes, I appreciate this.
Cool. I'm glad it's got good feedback. I was really had a lot of anxiety about trying to introduce it. All right.
It's cool. Thank you so much for sharing. And yeah, if you wouldn't mind sharing a link to either the issue or something so I can throw it in the YouTube channel, I'll stop the recording.